All right, this is my lab 4 looking over circuits, resistance, current, and ammeters. Table of contents, we got the introduction, data and observation, experiment, discussion, and conclusion. So in our introduction, the overall purpose is to observe and be able to make predictions looking at the use of EMF from resistors and circuits, as well as potential difference and conventional currents through capacitors. The fundamental principles here is the loop node rule for circuits, electrical potentials in circuits, and Ohm's law. In a preview of the results, the formula prediction for electrical potential values are equal to the values found in the circuit simulation. So overall, the system will be the circuit and the surroundings are anything outside of the circuit. So for part 1, the setup looks at having a circuit with two 1.5 volt batteries along with two ammeters and two resistors with ohms of 47 and 100. Therefore, total resistance is going to be 147 ohms. We can also predict that current 1 and current 2 are going to be equal to each other. The current calculated is 0.02 amps, and an open circuit has no current with the same potential difference. So as far as current differences go, you can see the differences here are B minus A is 3 volts, C minus B 0, D minus C negative 0.96, E minus D 0, F minus E negative 2.04, G minus F, H minus G, and A minus H is all 0. Our delta V turns out to be 0, and our current ends up being 0.0204. All of these locations were the ones that were chosen from the lab experiment guide. And when connected to an ammeter with 100 resistor, the current increased to 0.06. So for part 2, the setup was a 10 ohm and a 20 ohm bulb, a 9 volt battery, and a 200 mF capacitor. When first connected, the capacitor charges, and then the bulb lights up after the capacitor charges, or it lights up initially and then dims as the capacitor charges. But then when the battery is disconnected, everything discharges. It took about 10 seconds for the 10 ohm bulb, about 20 for the 20 ohm bulb. So looking at our time model, this is the linear association between the natural log of volts crossed with the time that the bulbs took to discharge. And you can see that it was pretty much a constant rate all the way until volts ended up hitting 0. So as far as potential sources of error goes, there is a potential fluctuation in timing and also potential issues with precision of calculations, looking at sig figs and potential round errors as well. So what if in this case you were to use a real life emitter, a real life emitter would have some sort of resistance in it, which would affect the results because the results would have an overall lower current due to the resistance. And in the same way, if you used a real circuit with no resistors would allow a battery to be fully charged faster, or a capacitor would be fully charged faster. However, the other thing with using a real circuit and real wires is that real wires do have resistance, whereas they were considered negligible in the circuits experiment that we have just completed. Real wires would need to be calculated for. This would be considered. So the circuit would be somewhat slower as to if we did an online evaluation of the same circuit, since this resistance would not be negligible. Thank you.